Hello and welcome to our last unit, which is on parabolas. Hopefully some of this will be review, some of it may be new. So let's start talking about the U-shaped graph of a quadratic function. As you know, that is called a parabola. The parent function is f of x equals x squared. I know you've been used to seeing it as y equals x squared. F of x means the function of x, which is just the fancy way of saying y equals. It's a function, so we're calling it f of x equals x squared. That is the parent function. So we're going to graph it. Now remember, when you're graphing, please graph with at least 5 points because it is a parabola. And you can either use a table of values or if you can do this in your head, that's great. Now let me show you. We'll start with 0, 0. And if we put in a positive 1 squared is 1, negative 1 squared is 1. So it looks like this. Now I want you to show you these 1, 3, 5 numbers. I know it sounds a little bizarre, but with a parent function from the vertex, if you go up 1 over 1, that's the first. If from that point I go up 1, 2, 3 and over 1, and of course the mirror image on the other side, because the y-axis happens to be the line of symmetry, and that's where you would plot the next one. And then I could go from that point to 4, I could go up 5 and over 1. It won't fit, but we'll talk a little bit more about that. It's our parabola as such. Okay, so let's talk about domain, range, and vertex. The domain are your x values. That would be all real numbers. So in case you forgot, make yourself a little note, x values. In interval notation, you would put a parenthesis around, since we can go in both the positive and negative direction forever, infinity. You would have negative infinity to positive infinity with parentheses. The range are your y values. And we always look at the vertex. We start at the vertex for this one because it goes up in a positive infinity direction, but it stops at 0, or starts, however you want to look at it. So we put a bracket around, and we start at 0, but we go to infinity, and with a parenthesis. Our vertex, that is either the highest or the lowest point. We'll get into more of that as we go along, but this is more of a review. It's 0, 0. Okay, so then we have what is called different forms of our equation, and we're going to start talking about vertex form first. Okay, vertex form. And this is your vertex form for quadratic equation. Okay, so every letter A, X, and K represent something. The X is just one of your X values in your infinite points. So your A value indicates could be a vertical stretch or shrink. So your A value is going to tell you how close or far away what it's going to look like from the x-axis. Okay, so you're looking to or from, I'll say, your x-axis. It also will tell you more information, like does it open up or down? Opens up or down, which means it's showing it might be reflected, a reflection, and that reflection would be on the x-axis. I'll just put x-axis underneath. Okay, the h, as you found out using the Desmos discovery, the h is your horizontal translation, so it just shifts that parabola left or right. Horizontal translation. And the k will make that parabola shift up or down, so that would be a vertical translation. Oh, excuse me. And the vertex, that is h, comma, k. Okay, so let's talk about the a little bit more. And we'll come down here. If your a value is negative, that means there was a reflection, so it's going to look like an upside down. It opens down. Then we have if the absolute value of a is greater than 1, it's going to be a very narrow parabola like this, the bigger the number. If your a value is between -1 and 1, so it's a fraction, it's going to be a very wide parabola like that. Okay, so it all depends on if you were to expand it, and we'll talk about what it may look like with the next 3 examples. Okay, so here we have our examples. We have f of x equals -1/2 x squared. Okay, so this tells us first, since a equals -1/2, that's important to notice, we have a reflection across the x-axis, and that's why it's going to open down. So it opens down. We have what's called a vertical stretch. Vertical stretch or shrink. Well, a is less than 1, so it's not going to be a stretch. It's actually going to be a shrink. So let's change that. It's going to be a vertical shrink because a is less than 1. It's going towards the x-axis. Okay, so that means it's going to be a wide parabola, and our vertex, well, we don't have an h and a k listed, so it's going to be 0, 0. Okay, so let's plot 0, 0, our vertex. Now, once you find a vertex, you know your line of symmetry. Remember your symmetry line when we did reflections and translations and so on? Well, the symmetry line was for reflections. And if we plug in 2, I'm using 2 because it's an easy number. 2 squared is 4, half of 4, and it's -1/2 of 4 is -2. So +2, -2. And then our mirror image. And if I put in 4 squared is 16, half of that is 8. I don't have that on my graph, so let me try 3. 3 squared is 9 times negative 1/2. That would give me negative 4.5. I can fit that. So 3, negative 4.5. And it's mirror image. And connect your dots. So I have my 5 points. Okay. Now, looking at number 2, it's a little different. We have a set that's in parentheses. Okay. So, notice that 2x is inside our parentheses. That means it's going to be a horizontal stretch or a horizontal shrink. I can rewrite this. G of x equals 4x squared, because 2 squared and x squared, plus 1 to take it out of parentheses. But just remember, and that's because of the parentheses here that's being squared, that makes it a horizontal shrink. Which means it's going towards the y-axis because a is greater than 1. So towards the y-axis, and that's because a is greater than 1. Alternatively, if once we multiply that out, we could also, looking at it here, say it's a vertical stretch. But that wasn't the original problem. That would be a vertical stretch. So we look at the original, and that's where we would say horizontal instead of vertical. Okay, the plus 1 at the end means we have a translation. Up, because it's positive, up 1 unit. And a is positive, so it's going to open up as a normal one parent function. And then our vertex, that's our HK. Well, we don't have an H, so that's 0. And our K, that's the plus 1. That's our vertex. Starting with the vertex. And then I always put in my axis of symmetry, as you might call AOS. Now, remember in the beginning I told you about the 1, 3, 5? 1, 3, 5. So the parent function would be up 1 over to the right 1. But that's when a was 1. It was just x squared. Since a is 4, you're actually going to multiply each by 4 when you move on. So from the vertex, I would go up 4, 1, 2, 3, 4, over 1, and it's mirror. Now, this is such a narrow graph, I can't fit anymore. So if I needed to, if I had a larger graph, I would, from that point, go up 12, 3 times 4, and over 1. But as we do these, I will continue discussing that 1, 3, 5 pattern. Okay, and there's graph number 2. One more graph and we are finished today. So, the last one. Now this is the vertex form that you're used to seeing, I think a little bit better. So let's talk about the whole thing. A is negative 1. A equals negative 1. So that means the reflection across the x-axis, and that means because it opens, it's a reflection, it's going to open or opens down. We have a translation because of the plus 2, so it's going to be translation. We're moving it up 2 units. And because there's a plus 3 inside, now remember, let me jump back here just for a moment, back to the original equation. Vertex form is x minus h. Since this says x plus 3, that means you're x minus a negative 3. That means you also have a translation to the left. 3 units. Okay, so our vertex, looking at our equation, our vertex, h is negative 3. Remember I said x minus a negative 3. That's what gives us the positive 3. And k is 2. That's your vertex. Our AOS, remember I keep talking about that axis of symmetry? AOS. That is a line, and that line I will show you when we plot negative 3, positive 2, that's our vertex. Our AOS, axis of symmetry, is that line, it's a vertical line, x equals negative 3. We'll talk about that more tomorrow. So let's continue graphing. If I plug in, now I'm not going to look at the 1, 3, 5 pattern as I talked about previously. Let's just, if we plot some points, if I plug in, substitute of course, value, how about negative 2, and you might want to do this on scratch paper. If I make x equal negative 2, it will look like this, plus 3 squared plus 2. That means y, and if you want to put a little xy table to help, if x is negative 2, what does y become? So we have negative 2 plus 3 is 1 squared times negative 1, that's negative 1 plus 2, so negative 2, 1. So let's plot negative 2, positive 1. That's nice. We have a mirror image on the other side, so I don't have to worry about that. Okay. And then what if I do negative 1 for x? I'll do this in a different color. So we have negative 1 plus 3 squared plus 2. So I get 2 inside my parentheses, squared 4. So I get negative 4 plus 2. So my y value is negative 2. So at negative 1, negative 2. And the mirror image. Now you want to see that 1, 3, 5 again. A is negative 1. That just means I'm going down. But it's 1 is the number I'm looking at. I can do the 1, 3, 5 down 1 over 1. From this point, I go down 1, 2, 3 over 1. I could do 1, 2, 3, 4, 5 over 1, and it would be down here. Just to give you an idea, then the matching one will be on this side. So the pattern is there, even in vertex form. But don't worry so much about that just yet. Okay, and that is a little review on parabolas. Don't forget what vertex form is, and don't forget your parent function. Okay, we'll see you for lesson 2 tomorrow.